So we are doing applications of our accumulation function. So looking at number one, the graph of f is shown. They do this whole uppercase f and lowercase f thing, which drives me crazy. But what I would do is ignore all of that. Do you see this part right here? That should trigger in your mind, fundamental theorem of calculus. You should go, oh, that's an integral. And what does this mean? Area, good, perfect. From where to where? Well, from 0, perfect. Okay, we got there. It's integral from 0 to 3 of this graph. You don't really need to read through all of that. It's just confusing, all right, is my opinion. So integral from 0 to 3. So we want the area from 0 to 3. So I can do the area from 0 to 1. That's a rectangle. How much is that worth? That's worth 2. Now I really can't do this because it's curved. So now I'm going to go back and read through all that mess that they gave me before. They're going to have to give you that in some capacity because they can't give you an undoable problem. How much is from 1 to 3 worth? Do you see how they give you that? 2.3. But it's confusing if you read that. They put the cart before the horse. Do you know what I'm saying? Like, just ignore that and go, hey, what do they want? So what's our total area? 4.3. D is in delightful. All right. Graph of a piecewise linear function is shown. They like to throw that vocabulary at you. Piecewise means it's broken into pieces. Linear means lines. It just means this graph right here. We want the value of area from -1 to 4. So let's do this. What shape is this? And it's right side up instead of on its side for once, okay? Now, if you don't like that it's a trapezoid, you could break it into a rectangle and 2 triangles, but let's review a trapezoid formula. It's 1/2 height, which is 2. Good, it's right side up for once. And then you add the bases together. So this one's 1, and this one is 3. All right, minus, now why am I doing minus for the other part? Below sea level. All right, now I would probably just break that into a square and a triangle because this is 1 and that's 1/2. So, 1 and 1/2. However it works best in your brain. Everybody thinks differently though. All right, and I heard somebody say this one. These cancel. This is 4 minus 1.5. So what is that? 2.5. B as in boa constrictor. Well, we're on our way. This is a Roman numeral one. And here's the suggestion that I make for this. You can't find these areas exactly because they're all curvy. I can't do areas unless like it's a triangle or a trapezoid or a semicircle, like something you could do an area of. So I would make up numbers, all right? So for this little area, I'm going to call that 2. Like I just invented that. If you're like, where'd you get that? I made it up just because it's easier to deal with numbers than like a blank. Do you get what I'm saying? Now, this little bump looks to be a little bit bigger than that one. So I'm going to call that one 3. And then this one looks to be a little bit smaller. So what do you maybe want to call that one? Yep, -1. It's a lot easier to deal with values though. So I would just assign them values because otherwise you're going, well, this one's a little bit more than that one, but this one's a little bit less than that one. And it becomes very clouded. All right. So let's go through these one by one. F of 0 is greater than F of 1. This is the derivative graph, so we're accumulating area. It's an accumulation function. F of 0, they tell us, is 0. So you start with nothing. So that's 0 greater than F of 1. Perfect. I thought I was going to have to pull teeth on that. Do you see how from 0 to 1, you get an area of 2? All right. Is that true? Is 0 bigger than 2? Not last time I checked. All right. Now let's try this one. F of 2. If you accumulate from 0 to 2, that's 5. And it says that's greater than F of 1, which we said was 2. Is that true? Yes. But see, follow me on this. If I didn't make up numbers, you would just be going, oh, well, both of these bumps together is larger than just that bump by itself. Do you get what I'm saying? Like, it becomes very like, what are we talking about? So if you make up numbers, it makes a little bit more sense. All right. And then F of 1, we said, is 2 greater than, all right, F of 3, you're going to go all the way to the end. So that would be 5 minus 1, just 4. So is 2 bigger than 4? No. So Roman numeral 2 only, B is in bubblegum. Because when you go all the way to 3, you're like, well, these 2 together minus that one is still bigger than just to here. Like, make up numbers. Just invent them. All right, this is an example of a free response question that you're going to see one similar to, I can guarantee it, on the AP exam. So it says g of x equals this. The very first thing you want to do is write g prime equals what? They will usually give you a point for that, just that. All right, and this is the graph of f, which means this is g prime, okay, which is good because that's your source that you're going to use to cite all your justifications. So let's go ahead and find all of our areas first before we like embark on this journey. Where does the accumulation start? 1. So I'm going to draw a line at 1. And let's find our areas. That first triangle there, 1/2 times 3 times 4. So that'd be 6, good. And then we're gonna have to break it right here. This is a half. And then this one is -1/2. But we're gonna have to do a trapezoid formula for this one. And the trapezoid is on its side, all right? So 1/2 height, what's the height? Perfect. And then add the bases together, 4 plus 1. So is that 5 halves or 2.5? All right, so now we have all of that. Let's go and compute these. G of 4, you're going to accumulate from 1 to 4. So start at 1, accumulate to 4. What are you going to get? It's 2.5. Perfect. And then G of -2, you're going to start at 1 and go to -2. Now you're going backwards to -6. Perfect. Gosh, you guys rock. So proud of you. Okay. Letter B. Oh, we survived that one. Good so far? All right. They will put a free response one like this on here, and you can get a 9 out of 9 on it. Like you can get all the points. It's very straightforward justifications, all right? State the critical points of G, label them as the location of relative maximum, relative minimum, or neither. How should the sentence start? G of X, good, perfect. G of X has a relative, let's look at the graph. We actually only have one critical point that we need to write a sentence about. 3. Why do we not need to write a sentence about -2? It's an endpoint. It can't be relative to anything. So you don't need to say anything about that one. All right, what does G have at 3? Good, perfect. G of X has a relative maximum at X equals 3 because you say it. I know I sound so hateful. I know I hate myself when I have to say that. I sound so hateful, but they will not give it to you if you say it. G prime. Perfect. Changes from positive to negative. I am the messenger. When I'm like super picky about that stuff, it's because that's how they're going to be to you on the AP exam. I'm really sorry. All right, this one says absolute. What does that mean we need to do? Candidates, perfect. All right, so your candidates are -2 and what else? 3 and 4. Yeah, that's it. Yeah. Oh yeah, I'm sorry. Go ahead. We didn't. Oh, hold on 1 second. All right, now 2 of these we actually already did. Yeah, what is 4 going to give you? Yeah, 2.5 and then -2 gives you -6. They do that a lot, which is kind of nice because then it's like you already did that work. All right. Where did our accumulation start in this one? 1. Okay, so we want to go from 1 to 3 is 3. Good. Now this one only asks for absolute minimum. So you don't have to write a sentence about absolute maximum. We're just going to say absolute minimum is -6 at X equals -2.
Do you not have to start with GMX hot?
You can if you want. I usually don't in that one because you don't have to write a because statement, so it normally doesn't trip people up. The reason I coach you to write G of X is or G of X has is because when you have to do a because statement, it starts you out on the right foot. You don't have to do a because statement on this one because that's it right there. So up to you. This is technically better grammar though, so I should have written them. Endpoints and critical points. You can put more points, but that's all you need. Okay. All right, points of inflection. Look at your sticky note. That's where G prime does what? Increasing to decreasing or decreasing to increasing. All right, so let's find them. And it says justify. So I will say G of X has inflection points at X equals. Actually, I think there might only be one. Yeah, just at one. Which is actually going to make the sentence shorter. G of X has inflection point. Well, I guess I should have said N inflection point. That's all right. At X equals 1 because G prime changes. Good. From increasing to decreasing there. Why didn't I have to also say or decreasing to increase? There's only one and the derivative changed from increasing to decreasing. So that shortened our less work. We like that, right? I like less work. All right, state the intervals where G is both increasing and concave down. This is really where that sticky note helps. Increasing would be where the derivative is positive and concave down, decreasing. So we need to find places on that graph that are positive. That means above sea level and decreasing. So where is that? 1 to 3. Perfect. All right, so now I wouldn't start this with G of X. Well, I guess you could say G of X is increasing and concave down from 1 to 3. I'm going to just write 1 to 3 because G prime is positive and decreasing there. Above sea level, but headed downwards. Do you remember particle motion and speeding up and slowing down? That's slowing down. Foreshadowing for next class, okay? We're going to revisit velocity and acceleration on that, but it's not any different. Just different words. It's the same thing we just did. Just calling it something different. Oh, here's where we're going to get a calculator a little bit for some of these. But yeah, I love, okay, we finally got to a word problem. We did enough like foundational work that we can do a word problem. I like actually making it a story, okay? All right. Now it says there are 250 M&Ms in a bowl at time 0. This is what is called an initial condition. That means that's what you start with. You know how sometimes they give you extra information that you don't use? An initial condition will never be that. It will always get used. So if you do the problem and you never use it on part A, B, or C, like you don't use it somewhere, you have done goofed. It is gonna get used. All right, that is not extra. So we start with 250 M&Ms in a bowl. The rate, oh, that means it is a what? A rate means it's a derivative. The rate at which they are being devoured, nom nom, is E of t equals blah, 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 M&Ms per minute. That's another thing that tells you it's a derivative, something per something else. So it's like kind of dissecting what they gave you there. How many M&Ms are in the bowl at time 3? It's accumulation. How many M&Ms have been accumulated or de-accumulated because we're eating them at time 3? Well, how many did you start with? 250. And we're going to subtract how many got eaten, which is an integral. So it will be from when to when? 0 to 3. And what goes in there? Yes, now you can write negative t squared plus 12t, or you can actually write e of t. It doesn't matter, but on the AP exam, you do realize they're going to give you absolutely obnoxious functions, right? You're better off writing e of t or whatever it is they've called it, because if you copy it wrong, guess what? It's wrong. All right, go ahead and slam that in the calculator. How do you do an integral? Math 9. Now, when you type it, you will have to type the actual thing. And use X. I know it says T, but type X. The calculator will never know, and it'll be our little secret. This is going really well. We will finish number 6. So we'll get through 1 through 6 today. What'd you all get? Yep. 205 M&Ms. So we started with 250. Some of them got eaten. Now we have 205. How would you be able to tell if you did it wrong? Yeah, if you got a number bigger than 250, that would not make sense because they're getting eaten. Does anyone need me to look at their calculator? I don't want the calculator are you good?
Yeah.
Okay, I don't want the calculator to be the issue. All right, part B, find the time at which the M&Ms are being eaten. That's a rate. The fastest, that's a maximum. So you want the maximum of this E of T. Maximums and minimums come from critical points. How do you get a critical point? Good, so it's E prime of T equals 0. And I suggest writing that because sometimes they'll give you a point if you just write that on the AP exam. Like you get a point for setting derivative equal to 0. All right, so what's the derivative of this thing? We'll do that by hand because it's easy. Yep, negative 2T. Perfect. Equals 0. Welcome back to algebra class. It has to be positive because it's time, but 6 minutes. So at 6 minutes is when they are being eaten the fastest. At 6 minutes is when everyone's like gobbling them up. Nom nom. All right. Set up the integral equation. So you're gonna have an integral and an equal sign that would give the time x at which the bowl empties. If it's empty, how many M&Ms are in it? 0. So you're gonna start with the 250 you had, subtract what got eaten. Now we did this in part A, it's just we did 0 to 3. This time we want it to be 0 to x. Good. E of t dt equals 0. You're not going to actually solve it. They do that a lot. They'll say set up, but do not solve the time at which the bowl would be empty. But we know that time would be more than what? 6, because 6 is when they're being eaten the fastest. So probably like 7 or 8.
So does it have to be X there? Or, like, if we
Unfortunately, yes, because it says at time
Oh.
X. So that's a directional thing. And usually they do give you that letter. It's funny, this one with X, usually they call it K. Is what I've seen most often. But yeah, just follow what they tell you to do. All right, and then this is the party one. People are arriving and leaving a party. Let me stand up because this is so important. This is what's called a rate in, rate out problem. That will be on the free response. It's usually the first or second question because those are the calculator ones and they give you a calculator for it. Rate in, rate out. This is people arriving and leaving. I have seen grain is falling into a pile and then it's also like being taken somewhere else. One year there was one, employees are putting bananas on a shelf and then customers are also taking them and purchasing them. That was a fun one, but it will be on there. Something will be happening and something else will be happening simultaneously. You got me? It will be there. All right. So people are arriving the party and leaving. They are arriving at a rate of this people per hour. So that is a derivative. Good. And they are leaving at 5 people per hour. What does that mean? That it's 5 people per hour. Well, 5 is what? Constant. They are leaving at a constant rate of 5 people per hour. Right there. Okay. Must not be a great party. All right. At what time is the party most crowded? That's a maximum. Maximums and minimums come from critical points. That is derivative equals 0. Now, these already are rates. So we're going to take our 40 e to the negative t minus 5. It's rate in minus rate out. And we're going to set it equal to 0. If you're like, hey, Ms. Cole, why didn't we take a derivative? Those already are derivatives. But Ms. Cole, back here, we actually took a derivative. We did E prime. That's because this one said being eaten, that's a rate, the fastest. It was a rate of a rate. Do you get, like, I know it's a lot. Put this in your calculator in y equals. Don't use t though, use x. So we can take a look at it. So you're gonna go to y equals, don't use t, use x. And hit zoom 6, that'll put it to a standard window. If you're given a window, then change it to that. But if they don't give you a window, then, you know, standard is a good place to start. Do you get a thing that looks like a ski slope? Oh, don't put the equal 0. Yeah, we're gonna calculate that. Zoom 6 will make it standard. That'll be -10 to 10. Sometimes they give you a window, in which case you can just put that. But if they don't give you one, I usually just say put Zoom 6. Does yours look like this? Okay, so we want to know where this equals 0. Do you see how it looks like it's about 2? But it's not exactly 2. All right. Do you remember how to calculate something on here? Good. Second trace. What are we going to choose off the list? 0. Now watch. It's about 2, right? So when it says left bound, I'm going to hit 1, enter. Right bound, I'm going to hit 3, enter. And guess, I'm going to hit 2, enter. I like to do it manually. You can also use the arrows and mess around with the cursor, but that gets really weird sometimes. So I usually just do it manually. 1, enter, 3, enter, 2, enter. Did you get 2.079? Okay. That's our answer. Well, that's our answer to the first part. And what is that, hours? So at time around 2 hours is when the most people are there. That's when the party's hopping. Okay. Now the next part of that is how many people are there. We need to accumulate people. You're going to have to reuse this number. Watch me show you how to type this because it's not hard, but you have to remember because I'm going to store that. You're going to quit out of there, hit clear and leave. Hit X, enter. That will bring it back. You see that? X, enter. And then do store alpha A, enter. Store alpha A, enter. Do you remember doing this in pre-calc? I know you did it because I just finished this unit with pre-calc where you did the law of sines and cosines and all that stuff. I'm seeing heads nodding. So store alpha A, enter. It does a copy paste for you is what we're doing. All right. So how would we set it up to find out how many people are there? It would be integral from what to what? To that, good, A. And then it would be 40e to the -t minus 5 dt. It's rate in minus rate out. Cool, thank you for heads nodding. I love that. All right, so you're gonna do math 9. 0 to alpha A, and then type that in. Again, use X, not T, because then you'd have to hit alpha T. You can use T if you want, but you have to hit alpha T. I don't even know where T is. T is the 4 button for reference. All right, so how many people are there when it's the most crowded? And they usually will, in this case, the directions will say, I know we always do 3 decimal points. They'll say round to the nearest whole number so that it's like a whole number of people. So we're going to say 25 people. That's a lot of people at the party. Well, I guess it's all relative. It depends on what the party is. Sounds like a lot of people to me. You guys didn't say much. Did you follow me through the storing? Because if all you do is type 2.079, this answer, well, if you round to a whole number, it might actually work. But if you had to do decimal points, it won't be accurate enough. And guess what? They won't give it to you. It's not accurate to 3 places. A lot of times they won't. All right, set up the integral equations. There will be an integral and an equal sign that gives the time when everyone's left. Think back to the M&Ms when the bowl was empty. I want to see if you can do this. It would be integral, well, 0 to x. 40e to the -t minus 5 dt equals 0. This one did not have an initial condition. You remember how the M&Ms had that 250? This one didn't have an initial condition, and I guess we're just to assume that the party started with 0 people, and then they started to arrive. I mean, that makes sense, right? And what is the net rate at which people are arriving at time 4? These are rates. So when they ask you for a rate, you're just going to use these. You don't need to take a derivative. You don't need to take an antiderivative. If they ask for the rate at time 4 and they give you the rates, all you're going to do is take 4 and plug it in, all right? So it would be 40e to the -4th minus 5. And don't stop listening to me when we finish this because we're going to talk about units for that. Oh, again, no one complained. You guys all found the E button? Remember that from last year? Okay.
-5 or -4?
It's -5. We plugged in 4 for time, but the rate,
Put 4 in the
oh, thank you. I would have gotten it wrong. Calculators drive me insane because if you type one thing wrong, it is wrong. I would have gotten that wrong. I'm actually glad I illustrated that for you. Do you see that? Now you can do a decimal for this one, and hold on, I'm going to explain why. We're going to talk about the units. Does anyone want to give it a try? What do you think the units are for that? Good, it's a rate, so people per hour. You can decimal point a rate of people per hour. And if you're like, hey, Miss Cole, you told us they were leaving at 5 people per hour. Why isn't that 5? It's because it says, what does that mean? Well, like you're including, yeah, like the total of people arriving, people leaving, the net rate at which they're leaving is a little bit like not 5. Okay, because some people are, maybe someone has their foot like halfway out the line.